Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. Please note that guys there are already 5 videos which are being uploaded whereby I'm tackling the past question papers, and I'm only focusing on Newton's laws of motion. Please guys, do click the link on the description below. You'll find a playlist whereby I'm answering all the 10 questions, and these 10 questions guys are from the grade 12 question papers. Please note that guys, it doesn't matter even if you're doing grade 11. Why am I saying that? Because Newton's laws are taught in grade 11. Excuse me. So even if you're doing grade 11, the fundamental principles are still the same. Excuse me guys. And the other playlist that you'll find there in the description is for those who still want to learn Newton's laws from scratch. You guys will choose which playlist you want to go for based on your own understanding. Before we even start guys, please don't forget to share this video to your peers. A thing or two that I will mention here, I believe it will help them whether prepare for their upcoming test or an upcoming exam, or even elevate their knowledge in Newton's laws. And please don't forget to like, comment. You can ask the questions in the comment sections if there are things that troubles you, and most importantly, please do subscribe guys, just to help us grow the channel. Okay, thank you very much. We are told that a crate of mass 2 kg is being pulled to the right across a rough horizontal surface by a constant force F. The force F is applied at an angle to the horizontal as shown in the diagram below. Draw a free body diagram showing all the forces acting on the crate. Okay, I will draw 2 body diagrams here. Is this thing moving on a rough horizontal? Yeah, it's a rough horizontal surface. So we have frictional force. You can draw your free body diagram like this. You obviously have your normal force, F normal, and then you have an applied force at an angle. Do indicate there 30 degrees. You obviously have your gravitational force, weight, and we have our frictional force, kinetic friction. Okay, so one person guys would prefer to draw their free body diagram like this, but I prefer using components of I'll prefer using components of this force which is applied at an angle. Ne? So my free body diagram will be like this. I'll simply have I will also have normal force, F normal, and then I will have the vertical component of the force. The vertical component of the force is just equals to F sine theta, and the theta just represents the angle between the force and the horizontal surface. Are you together? Since we have a horizontal component, let me rather indicate the horizontal component with a different color, like this one. Let me use blue for the components of the force, both vertical and horizontal. And then this one, Fx, which is horizontal, this will be equals to the magnitude of F multiplied by the cos of theta. Are you together? And obviously you still have your gravitational force, which is your weight, and also your frictional force, your kinetic friction. I prefer using this one. Are you together? But you can still draw this one. You'll still get your full marks. Okay, and then now we are told that a constant frictional force of 3 newtons acts between the surface and the crate. A constant frictional force of 3 newtons acts between the surface and the crate. The coefficient of kinetic friction between the crate and the surface is just 0.2. Okay. We must calculate the magnitude of normal force. How can we do that? Remember that, guys, kinetic friction is just coefficient multiplied by normal force. Are you together? If the kinetic friction is 3, and then the coefficient is just 0.2, we'll just divide both sides by 0.2. 3 divided by 0.2, you'll simply get to 15 newtons. So the magnitude of normal force is just 15 newtons. Let me rather denote it as Fn. I'm denoting in normal force as Fn. Friction is always kinetic of friction multiplied by normal force. Coefficient of friction rather multiplied by normal force. And then now they want us to calculate force F. We can use we can use our free body diagram. This is why I prefer using this form of a free body diagram, because now I can easily calculate the magnitude of F. Are you together? Remember that, guys, F net, according to Newton's second law, is equal to ma. But F net is sum of all the forces in one dimension. Are you together? If we take up as positive, that means we have our normal force Fn plus our vertical component minus or plus a negative gravity, because gravity is moving in an opposite direction, right? Is equals to ma. But since our crate is not moving vertically, it simply means that, guys, our crate is not accelerating up or downwards. It simply means the vertical acceleration is 0, number one. And if the vertical acceleration is 0, that means F net for the horizontal forces is also 0. So I'll just place a 0 over there. All right, together. For the applied force, I just got 15 newtons, which are not applied force rather, but no, the normal force. I just calculated it to be 15 newtons. I do know that the vertical component is just F multiplied by sine theta. Sine theta is just the theta is just the angle between the force and the horizontal, minus the weight. The weight is just mass multiplied by 9.8. That's 2 multiplied by 9.8 is equals to 0. So F sine of 20 degrees minus 15 minus 19.6, isn't it minus 4.9? Let me check. 15 minus 2 times 9.8. Oh, that's a 4.6, not 4.9. 4.6, no? And then I know that F multiplied by sine of 20 degrees is just equals to 4.6. Divide both sides by sine 20. Then I'll simply have 4.6 divided by the sine of 20 degrees. I'll simply get the force, the magnitude of F to be equals to 13.45 newtons. So the magnitude of force F, guys, is just 13.45, ne? 13.45 newtons. Okay, and then 2.1.4, they want us to calculate the acceleration on the crate. The acceleration on the crate, I think let me answer this question. Write it there at the top. If we focus, guys, on the horizontal forces, because our crate is accelerating horizontally, that means F net on the horizontal dimension, F net is equals to MA. Ne? We'll simply have Fx, which is pulling the box towards the right, plus a negative frictional force is just equals to MA. Fx is just F cos of 20 degrees. Ne? We do know, okay, let's just say minus Fk is equals to 2a. We don't know the value of acceleration. Ne? We just calculated the value of F to be equal to 13.45. So here we can simply substitute 13.45 multiplied by the cos of 20 degrees minus frictional force, which is 3, and I have 2a over here. Ne? If I divide both every term by 2, I'll simply have a is equals to 13.45 multiplied by the cos of 20 degrees minus 3 all over 2. I'll simply get an acceleration of 4.82 meters per second to the right. They wanted the magnitude only. Ne? I'll just say 4.82 meters per second. I answered here, guys, without even assigning the direction. Please, guys, always take direction of motion as positive. Ne? Since there's applied force which is being applied towards the right, that means every movement towards the right has to be positive. That's why the horizontal component was positive and the frictional force was negative. Why? Because friction is moving towards the left, the horizontal force is moving towards the right. Are we together, guys? So that's I answered without assigning direction. Please don't kill me. Okay, state the Newton's law of universal gravitation in words. It simply states that any particle in the universe will attract any other particle with a gravitational force which is directly proportional to the masses of those particles and inversely proportional to the square of their distance apart from their centers. Okay, and then now we are told that 2.2.2, how does the magnitude of the gravitational force exerted by the earth on the rock change as the distance between the rock and the earth becomes smaller? Okay, remember that, guys. The law simply states that the force is directly proportional to the product of the masses and it's inversely proportional to the square of their distance apart. You can use d squared or r squared, is up to you. No? Okay, so if, guys, you are decreasing your distance, the distance apart from their centers, you are actually increasing the gravitational the gravitational force exerted by the earth on the rock. Are you together? Why am I saying that? Because the distance apart and the force are inversely proportional. If you change one of them, the other will be an opposite change. Are you together? So by decreasing the distance apart, you are increasing the value of the force. Are you together? You can write this thing, guys, as your reason. That's how nice physics is. But you can simply say, because the square of the distance apart is inversely proportional to the force. So once you decrease the force, you are actually once you decrease rather the distance apart from their centers, you are actually increasing the gravitational force. That's how, guys, we're supposed to tackle this question. I really hope that, guys, the video helped you out. Please don't forget to comment, like, and subscribe. Thank you very much.